Good morning, everybody. I'm Sridhar Rao, Department of Mathematics, taking you a Zoom online class on asymptotes. Is my voice audible?
Good morning, sir.
Good morning. Yes. Okay, right.
Yes, it is audible.
Sir, audible.
Yes. Thank you. So let us take one example how to find the asymptotes to a curve. You have to find all the asymptotes in the sense asymptotes parallel to coordinate axis, that is parallel to both x-axis and y-axis, and also asymptotes not parallel to coordinate axis. They are called oblique asymptotes. Here the given equation is x square y square equals a square into x square plus y square. So the given equation is x square y square equals a square into x square plus y square. You have to find the asymptotes parallel to this coordinate axis first. Next, asymptotes not parallel to coordinate axis. To find the asymptote parallel to x-axis, you must equate the coefficient of the highest power of x to 0. That is here, the coefficient of highest power of x. There are two terms containing x square here. One is x square y square and another one is a square x square. Bring that a square x square to the left hand side so that what you will get is the coefficient is y square minus a square. Taking x square as a common factor there, the coefficient becomes y square minus a square. You have to equate y square minus a square to 0 to find the asymptote parallel to x-axis. So y square minus a square is the coefficient of the highest power of x, that is x square. X square in a coefficient ideyala, that is y square minus a square. Andre x square pakkadalli baruva number ge usually we call that as coefficient. So it is y square minus a square equal to 0. That implies y equals plus or minus a. It has two asymptotes parallel to x-axis. Similarly, we have to find the asymptote parallel to y-axis. For that, you have to equate the coefficient of the highest power of y. Here, the highest power of y is y square. Its coefficient is y square. There are two terms containing y square. One is x square y square and another is a square y square in the right hand side. Group those two terms. What you will get is the coefficient is x square minus a square. So the coefficient of the highest power of y, that is y square, is x square minus a square. So asymptote parallel to y-axis is given by, you have to equate the highest power of y, the coefficient of the highest power of y, that is y square, its coefficient, you have to equate it to 0. So here the coefficient is x square minus a square equals 0 because you have to equate it to 0. So that you will get x equals plus or minus a. You have got again two asymptotes parallel to y-axis. So finally what you have got herein is two asymptote parallel to x-axis, two asymptote parallel to y-axis. But the degree of the equation observed here. Here the degree of the equation is at most degree is 4 because x square is there, y square is there, its power is 2 plus 2, that becomes 4. So 2 plus 2 is 4. Therefore, it can have at most 4 asymptotes, but already you have got 4 asymptotes. What are the 4 asymptotes? One is y equals plus a, another one is y equals minus a, and another one is x equals a, and one more x equals minus a. Totally you have got 4 asymptotes. Somebody should unmute. I should check which one is not being muted here. Just mute yourself. Otherwise, I will have the disturbance here. Okay, right. Now I shall continue this. Totally, it has 4 asymptotes because the degree of the equation is 4. Is there a necessity to find the oblique asymptotes in this case? No, because already we have got 4 asymptotes, and degree of the equation is also 4, because x square, y square, if once you add those, you will get 4. 2 plus 2, that is 4. Power degree is 2, and y power is also 2. If you add those two, at most degree is 4. Therefore, it cannot have more than 4 asymptotes. So here, already we have got 4 asymptotes: y equals plus a, y equals minus a, x equals plus a, and x equals minus a. Therefore, no need to find oblique asymptotes in this case. So you have to observe the problem right from the beginning here. Further, the degree of the equation of the curve is 4. Thus, the number of asymptotes does not exceed 4. Hence, there are no oblique asymptotes. The only asymptotes are x equals plus or minus a and y equals plus or minus a. ಅದರಿಂದ ಇಲ್ಲಿ ಆಬ್ಲಿಕ್ ಅಸಿಂಪ್ಟೋಟ್ಸ್ ಕಂಡುಹಿಡಿಯುವ ಪ್ರಮೇಯವೇ ಬರೋಲ್ಲ. ಯಾಕೆ ಬರೋಲ್ಲ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ 4 ಅಸಿಂಪ್ಟೋಟ್ಸ್ ಬಂದಿದೆ. ಯಾಕೆ 4 ಬಂದಿದೆ ಅಂದ್ರೆ ಡಿಗ್ರಿ 4 ಇದೆ, ಇಲ್ಲಿ 4 ಬಂದ್ಬಿಟ್ಟಿದೆ ಆಲ್ರೆಡಿ. ಆದ್ರಿಂದ ಇನ್ನು 5ನೇ ಅಸಿಂಪ್ಟೋಟ್ಸ್ ಅಸ್ತಿತ್ವದಲ್ಲಿ ಇರಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಬಿಕಾಸ್ ಡಿಗ್ರಿ ಇಸ್ 4, ಇಟ್ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಅಟ್ ಮೋಸ್ಟ್ 4 asymptotes. So therefore, you need not have to find the oblique asymptotes here. Already 4 asymptotes bandidrinda. Now let us move on to the next problem. Find all the asymptotes to the curve 4x square into y minus x plus y into y minus 2 into x minus y equals 4x plus 4y minus 7. Find all the asymptotes to the curve 4x square into y minus x plus y into y minus 2 into x minus y equals 4x plus 4y minus 7. Let us regroup this. The given equation, what is given is actually 4x square into y minus x plus y into y minus 2 into x minus y equals 4x plus 4y minus 7. This implies 4x square into y minus x plus y into xy, that is, I am multiplying this here, minus 2x minus y square plus 2y, and taking that 4x plus 4y minus 7 to the left hand side, you will get minus 4x minus 4y plus 7 equals 0. Again, simplifying further, you will have minus y cube plus xy square plus 4x square y minus 4x cube. This is just by multiplication, plus 2y square minus 2xy minus 4x plus 4y plus 7. Why I have arranged this in this order is because the first term in the bracket, that is minus y cube plus xy square plus 4x square y minus 4x cube, here the degree, if once you add the degree there, you will get 3, because y cube, its power is 3. Xy square, its power is also 3, because x power 1 is there, y square is there, add the powers 3. Similarly, 4x square y, that is also power is 3, because y power is 1, x power is 2, 2 plus 1 is 3. 4x cube, its power is also 3. So they should be arranged in a homogeneous of same degree. So therefore, the first term in the bracket, in the ordinary bracket, you have a first term having 4 terms here. All the 4 terms are of degree 3, that is H3. You can denote that as capital H3, plus second term in the ordinary bracket, that is 2y square minus 2xy. Here degree, observe the degree. So y power is 2. So y power is 2. And 2xy is there. X power is 1 and y power is 1. Add that to 2. Therefore, that is H2. So I must observe this. It should be homogeneous of the same degree here. Therefore, y square, its power is 2. 2xy, x power is 1, y power is 1. Add that. 1 plus 1 is 2. Therefore, it is a homogeneous of degree 2. Next, third term is 4x plus 4y with negative sign. That is, its power is, x power is 1, y power is 1. Therefore, it is capital H1. It is homogeneous of degree 1. 7, it doesn't contain x, it doesn't contain y. Therefore, it's homogeneous of degree 0, that is. So therefore, here the coefficients of the highest power of x and y, that is of x squared and x cube, are constants. Therefore, no asymptotes parallel to coordinate axis. Coordinate axis ಗೆ parallel ಆಗಿ ಯಾವ asymptotes ಇಲ್ಲ. ಯಾಕಿಲ್ಲ ಅಂದ್ರೆ highest power of x ಅಂದರೆ -4 ಅದು. ಅದರ ಕೋಎಫಿಷಿಯಂಟ್ ಇದೆಯಲ್ಲ ಎಕ್ಸ್ ಕ್ಯೂಬ್ ಇದೆಯಲ್ಲ, ಎಕ್ಸ್ ಕ್ಯೂಬಿನ ಕೋಎಫಿಷಿಯಂಟು -4 ವಿಚ್ ಇಸ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್. ದೇರ್ ಫೋರ್ ನೋ ಅಸಿಂಪ್ಟೋಟ್ ಪ್ಯಾರಲಲ್ ಟು ಎಕ್ಸ್ ಆಕ್ಸಿಸ್. ಹಾಗಿದ್ರೆ ನೋ ಅಸಿಂಪ್ಟೋಟ್ ಪ್ಯಾರಲಲ್ ಟು ವೈ ಆಕ್ಸಿಸ್. ಯಾಕೆ? ವೈ ಕ್ಯೂಬ್ ಇದೆಯಲ್ಲ ಅದರ ಕೋಎಫಿಷಿಯಂಟ್ ಯಾವುದು? -1. -y ಕ್ಯೂಬ್ ಇದೆ.
Constant.
So that is also a constant. Because it is constant, there is no asymptote parallel to y axis. ಅಲ್ಲಿಗೆ ಎರಡು ಅಸಿಂಪ್ಟೋಟ್ಸ್ ಇಲ್ವೇ ಇಲ್ಲ. ಇದಕ್ಕೆ ಯಾವುದು? ಅಸಿಂಪ್ಟೋಟ್ ಪ್ಯಾರಲಲ್ ಟು ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಇಲ್ಲ, ಅಸಿಂಪ್ಟೋಟ್ ಪ್ಯಾರಲಲ್ ಟು ವೈ ಆಕ್ಸಿಸ್ ಇಲ್ಲ. ಆದ್ರಿಂದ ಇದಕ್ಕಿರೋದು ಬರೇ oblique asymptotes. How to find the oblique asymptotes? The given equation is written in the form h3 plus h2 plus h1 plus h0 equals 0. h3 ಅಂದ್ರೆ ಯಾವುದು ಅಂದ್ರೆ -y cube plus xy square plus 4x square y minus 4x cube. h2 ಅಂದ್ರೆ ಯಾವುದು? 2y square minus 2xy. h1 ಅಂದ್ರೆ ಯಾವುದು? -4x plus 4y. h0 ಅಂದ್ರೆ ಯಾವುದು? 7. Next step in the procedure is put x equals 1 and y equals m in the above equations. What you will get is x ಇರಲಿ 1 substitute ಮಾಡಬೇಕು, y ಇರಲಿ m substitute ಮಾಡಿದರೆ you will get -m cube plus m square plus 4m minus 4, 2m square minus 2m minus of 4 plus 4m plus 7 equals 0. First one you rename it. How do you rename it? Rename it as pi 3 of m. So pi 3 of m is -m cube plus m square plus 4m minus 4. Second one ideyala, that is pi 2 of m. You have to rename it as pi 2 of m, 2m square minus 2m. And pi 1 of m ಬೇಕಾದ್ರೆ ಬರ್ಕೋಬಹುದು, ಬೇಡದ್ರೆ ಬಿಡಬಹುದು. pi 1 of m ಅಂದ್ರೆ ಯಾವುದು? -4 plus 4m. pi 0 of m ಇವೆಲ್ಲ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಆದ್ರಿಂದ ಇಲ್ಲಿ ಬರಲಿಲ್ಲ. pi 0 of m is 7. pi 2 of m is 2m square minus 2m. ನೆಕ್ಸ್ಟ್ ಪ್ರೊಸೀಜರ್ ಅಲ್ಲೇ ಇದೆ. ಹೇಗಿದೆ ಅಂದ್ರೆ ವರ್ಕಿಂಗ್ ರೂಲ್ ಅಲ್ಲಿ ಇದೆ ನೋಡಿ. ಸಾಲ್ವ್ pi 3 of m equal to 0. ಹೈಯೆಸ್ಟ್ ಡಿಗ್ರಿ ಇರೋದನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. pi 3 of m equals 0. pi 3 of m ಅಂದ್ರೆ ಯಾವುದು? -m cube plus m square plus 4m minus 4 equals 0. You have to solve this equation. It's a cubic equation. So I can solve this by taking the common factors there. That is m minus 1 into 4. In the first two terms, what you can take common is m square. In the second last two terms, you can take 4 common. 4 common ತೆಗೆದಾಗ what you will get is m minus 1 into 4 minus m square equal to 2. Therefore, m equals 1. So ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡೋದು ಹೇಗೆ? ಫಸ್ಟ್ 2 ಟರ್ಮ್ಸ್ ಅಲ್ಲಿ m ಸ್ಕ್ವೇರ್ ಕಾಮನ್ ತೆಗಿರಿ, ಲಾಸ್ಟ್ 2 ಟರ್ಮ್ಸ್ ಅಲ್ಲಿ 4 ಅನ್ನು ಕಾಮನ್ ತೆಗಿರಿ. So that you will get m minus 1 into 4 minus m square equals 0. So it has how many roots? 3 roots. What are the 3 roots? 1, 2 and -2. All the 3 roots are non-repeated. ಯಾವ ರೂಟು ರಿಪೀಟ್ ಆಗಲಿಲ್ಲ. ಅಂದ್ರೆ 1 ಬಂದ್ರೆ ಇನ್ನೊಂದು 1 ಬಂದಿಲ್ಲ, 2 ಬಂದ್ರೆ ಇನ್ನೊಂದು 2 ಬಂದಿಲ್ಲ, -2 ಬಂದ್ರೆ ಇನ್ನೊಂದು -2 ಬಂದಿಲ್ಲ. They are non-repeated roots. Non-repeated roots ಗೆ ಅಸಿಂಪ್ಟೋಟಿನ ಈಕ್ವೇಶನ್ y equals mx plus c ಇದೆಯಲ್ಲ, ಆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ m ಗೆ c ಕಂಡುಹಿಡಿಯೋದು ಹೇಗೆ ಅಂತ ಪ್ರೊಸೀಜರ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದೆ. ನಾನ್ ರಿಪೀಟೆಡ್ ರೂಟ್ಸ್ ಗೆ, so they are all distinct. All the roots are different. Therefore, you have to find c. For that, we require pi 3 dash of m. So pi 3 dash of m. Pi 3 dash ಅಂದ್ರೆ differentiation with respect to m. So -m cube ಅನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದರೆ -3m square, m square ಅನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದರೆ 2m, -4 ಅನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ +4m ಅನ್ನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದರೆ 4, -4 ಅನ್ನೋದು ಕಾನ್ಸ್ಟೆಂಟ್, ಅದರಿಂದ ಅದರ ಡಿಫರೆನ್ಶಿಯೇಷನ್ 0. So pi 3 dash of m is -3m square plus 2m plus 4. The corresponding value of c is given by working rule alle ide ನೋಡಿ. non-repeated roots ಗೆ c ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಫಾರ್ಮುಲಾ -pi 2 of m. ಅಲ್ಲಿ pi n minus 1 of m ಇದೆ. n 3 ಆಗಿದ್ದರಿಂದ 3 minus 1 ಅಂದ್ರೆ 2. Therefore, pi 2 of m divided by pi 3 dash of m. This is the formula which was given in the working rule in the last class. Therefore, c equals minus of, what is pi 2 of m? 2m square minus 2m. Pi 3 dash of m minus 3m square plus 2m plus 4. Next, give the values for m equals 1, 2, and minus 2, so that you will get the 3 values for C. So the first one is, if you put m equals 1, if you put m equals 1, C value is 2 minus 2, because m equals 1 substitute madidre, minus 3 plus 2 plus 4. Therefore, you will get 0. C value is 0. Corresponding to the slope m equals 1, you have got the intercept C equals 0, because asymptote bekadre y equals mx plus c, m beku, c nu beku. m ಗೆ 1 ಆದಾಗ c is 0 ಆಯ್ತು. Similarly, for m equals 2 substitute ಮಾಡಿದ್ರೆ, c is given by 8 minus 4 minus 12 plus 4 plus 4. You will get minus 1. So c value is minus 1. Intercept value is minus 1. Slope value is 2. Next, corresponding to m equals minus 2, c value is 8 plus 4 whole divided by minus 12 minus 4 plus 4 equals minus 1. Therefore, c value is minus 1. m value ಬೇರೆ ಬೇರೆ ಇದೆ, but c value ಎರಡು ಒಂದೇ ಬಂದಿದೆ ಇದರಲ್ಲಿ. m ಗೆ 2 ಇದ್ದಾಗ c value minus 1, m ಗೆ minus 2 ಇದ್ದಾಗಲೂ c value minus 1. So you got 3 c's corresponding to 3 m's. Therefore, asymptote is given by y is equal to mx plus c. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, asymptote is given by y equals mx plus c. m1 ಆದಾಗ c ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, ಆವಾಗ y equals x ಬರುತ್ತೆ. ym ಆದಾಗ c minus 1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್, m ವ್ಯಾಲ್ಯೂ 2 ಆದಾಗ c ವ್ಯಾಲ್ಯೂ minus 1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, y equals mx plus c ಅಂದಾಗ y equals 2x minus 1. And similarly, y equals minus 2x minus 1. Y equals minus 2x minus 1. So therefore, the 3 asymptotes are y equals x is nothing but x minus y. So therefore, x minus y equal to 0. Next, another asymptote is 2x minus y minus 1 equal to 0. And another asymptote is 2x plus y plus 1. Yes, it has 3 asymptotes. Obviously, 3 asymptotes irreleveku, because what is the degree of the equation here? Highest degree 3 iradrinda. So it should have 3 asymptotes. Already 3 asymptotes bandide, but there are no asymptotes parallel to x-axis and parallel to y-axis. Now we shall take up the next problem, that is problem number 4. Find all the asymptotes to the curve x cube minus x square y minus xy square plus y cube plus 2x square minus 4y square plus 2xy plus x plus y plus 1 equal to 0. Problem looks to be lengthy, but solution is simple. The given equation is x cube minus x square y minus xy square plus y cube plus 2x square minus, ಅಂದರೆ ರೀಗ್ರೂಪ್ ಮಾಡಿದೆ. ಇದನ್ನು ಹೇಗೆ ರೀಗ್ರೂಪ್ ಮಾಡಿದೆ? ಡಿಗ್ರಿ ಒಂದೇ ಬರೋ ರೀತಿಯಲ್ಲಿ ನೀವು ರೀಗ್ರೂಪ್ ಮಾಡಿದೆ. ಫಸ್ಟ್ ಅಲ್ಲಿ ನೋಡಿ, ಗಮನಿಸಿ, ಫಸ್ಟ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಇರೋದನ್ನ ಆಲ್ ಆಫ್ ದೆಮ್ ಆರ್ ಆಫ್ ಡಿಗ್ರಿ 3. ಎಕ್ಸ್ ಕ್ಯೂಬ್ ಇದೆ, ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ವೈ ಅಂದ್ರೆ y ಪವರ್ 1 ಮಾಡ್ಕೊಂಡು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ 2 + 1 3 ಮೈನಸ್ ಎಕ್ಸ್ ವೈ ಸ್ಕ್ವೇರ್ ಇದೆ, ಎಕ್ಸ್ ಪವರ್ 1 ಮಾಡ್ಕೊಂಡ್ರೆ ಪವರ್ ಅನ್ನು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ 3 ಪ್ಲಸ್ ವೈ ಕ್ಯೂಬ್. ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಡಿಗ್ರಿ 2 ಇರೋದನ್ನೇ ಒಂದ್ ಕಡೆ ಗ್ರೂಪ್ ಮಾಡಿದೆ. 2x ಸ್ಕ್ವೇರ್ ಮೈನಸ್ 4y ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2xy ಅಂದ್ರೆ x ಗೆ ಪವರ್ 1 y ಗೆ ಪವರ್ 1 ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ 2. ಥರ್ಡ್ ಒನ್ ಅಲ್ಲಿ x ಪ್ಲಸ್ ವೈ ಬರ್ದಿದೆ, ಯಾಕೆಂದ್ರೆ ಡಿಗ್ರಿ 1 ಇರೋ ಟರ್ಮ್. ಲಾಸ್ಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆಯಲ್ಲ, ಅದು ಡಿಗ್ರಿ 0 ಇರೋ ಟರ್ಮ್. ಸೊ ನೆಕ್ಸ್ಟ್, I have given there that there are no asymptote parallel to coordinate axis y. Can anybody tell me?
Constant coefficients.
ಯಾವುದಕ್ಕೆ? x ಕ್ಯೂಬಿಗೇನೋ ಆಗಿದೆ, ಆಮೇಲೆ y ಕ್ಯೂಬಿಗೆ
ಅದಕ್ಕೂ ಕಾನ್ಸ್ಟೆಂಟ್.
ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. Since the coefficient of x cube and y cube, they are constant, therefore no asymptote parallel to coordinate axis. Next, you have to find the oblique asymptotes. ಅದಕ್ಕೆ ಪ್ರೊಸೀಜರ್ ಏನು ಹೇಳಿ? put x equals 1 and y equals m in the above given equation. ಅದರಲ್ಲಿ x equals 1 substitute ಮಾಡಿ, y ಇರಲ್ಲಿ m substitute ಮಾಡಿದಾಗ you will get first term is m cube minus m square minus m plus 1, and second term ಅಲ್ಲಿ x equals 1 and y equals m substitute ಮಾಡಿದಾಗ 2 minus 4m square plus 2m, and in the third term you will get 1 plus m plus 1 equal to 0. Here pi 3 of m, that is the first term, remember, m cube minus m square minus m plus 1. Pi 2 of m is 2 plus 2m minus 4m square. And pi 1 of m is 1 plus m. Pi 0 of m ಬರೆದಿಲ್ಲ, ಬರೀಬಹುದು. ದಟ್ ಈಸ್ 1. ನೆಕ್ಸ್ಟ್, ನಾವು pi 3 of m is 0. ದಟ್ ಈಸ್ ದಿ ಪ್ರೊಸೀಜರ್ ಅಲ್ಲೇ ಇದೆ. ಯು ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್ pi n of m ಅಂತ ಇದೆ. ಇಲ್ಲಿ n 3 ಆಗಿದ್ರಿಂದ ಯು ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್ pi 3 of m equal to 0. In other words, m cube minus m square minus m plus 1, that is pi 3 of m, that is equal to 0. Again, ಇಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಇಟ್ಸ್ ಎ ಕ್ಯೂಬಿಕ್ ಈಕ್ವೇಶನ್. Quite simple problem this is. You have to take m square common in the first two terms. First two terms ಅಲ್ಲಿ m square common ತೆಗೆರಿ. Second one ಅಲ್ಲಿ minus common ತೆಗೆದುಬಿಡಿ. last two terms ಅಲ್ಲಿ minus 1 common ತೆಗೆದ್ರೆ what you will get is m minus 1 whole square into m plus 1 equals 0. Next, m minus 1 whole square implies it has two roots. M minus 1 whole square equals 0 implies m equals 1 repeats twice. Square irodrinda m minus 1 whole square irodrinda, so m equals 1 repeats twice. Repeat agutte, bariyadu hege 1 comma 1, yakandre m minus 1 whole square irodrinda. Second one alli power enilla, adrinda it has only one root, m equals minus 1. So here you have a repeated root. So 1 comma 1 is a repeated root. ಹಿಂದಿನ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಏನಾಗಿತ್ತು, ದೇ ಆರ್ ಆಲ್ ನಾನ್ ರಿಪೀಟೆಡ್ ರೂಟ್ಸ್. ಅದರಿಂದ ಅದಕ್ಕೆ ಇರುವ ಫಾರ್ಮುಲಾನೇ ಬೇರೆ, ಸಿ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಇದಕ್ಕಿರುವ ಫಾರ್ಮುಲಾನೇ ಬೇರೆ. ನೋಡೋಣ ಹೇಗೆ ಅಂತ. ಫಸ್ಟ್ ನಾನ್ ರಿಪೀಟೆಡ್ ರೂಟ್ ಯಾವುದು? ನಾನ್ ರಿಪೀಟೆಡ್ ರೂಟ್ ಇಸ್ -1. ಅದಕ್ಕೆ ಸಿ ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋಣ. ಅದಕ್ಕೆ ಸಿ ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋದು ನಮ್ಗೆ ಹೇಗೆ ಹೇಳಿ ಗೊತ್ತು, ಹಿಂದಿನ ಪ್ರಾಬ್ಲಮ್ ಟೈಪ್ ಅದು. ಬಿಕಾಸ್ -1 ಇಸ್ ನಾನ್ ರಿಪೀಟೆಡ್, ಅದಕ್ಕೆ ಅದೇ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. Corresponding to non-repeated roots of pi 3 of m equal to 0, the value of c is given by c equals minus pi 2 of m divided by pi 3 dash of m. Pi 3 dash of m under differentiation. c equals minus of pi 2 of m 2 plus 2m minus 4m square. Pi 3 dash of m is 3m square minus 2m minus 1. Next, for m equal to -1, because -1 is non-repeated value here. 1 ತಗೊಳ್ಳೋ ಹಾಗಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಅದು ರಿಪೀಟೆಡ್, ಅದನ್ನು ಇಲ್ಲಿ ಬಳಸೋ ಹಾಗಿಲ್ಲ. ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಓನ್ಲಿ ಟೇಕ್ ನಾನ್ ರಿಪೀಟೆಡ್ ರೂಟ್ಸ್, ರಿಪೀಟ್ ಆಗಿರಬಾರ್ದು ರೂಟ್ಸ್. -1 ಅನ್ನೋದು ಒಂದೇ ಸರಿ ಬಂದಿದೆ, 2 ಸರಿ ಬಂದಿಲ್ಲ. ಅದರಿಂದ m equals -1 is a non repeated root. Corresponding value of c is ಅಲ್ಲಿ m ಇರಲಿ -1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ -2 minus 4 by 3 plus 2 minus 1 on simplification that yields 1. So therefore 1 asymptote ಬಂತು. ಹೇಗೆ ಬಂತು? m equals -1 ಆದಾಗ c is 1, y equals mx plus c ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಅದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಅಸಿಂಪ್ಟೋಟಿನ ಈಕ್ವೇಶನ್ ಯಾವಾಗಲೂ y equals mx plus c, m -1 c 1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ you will get y equals -x plus 1, that is x plus y minus 1 equals 0 is 1 asymptote. ನೆಕ್ಸ್ಟ್, ಉಳಿದ ಅಸಿಂಪ್ಟೋಟ್ ಅನ್ನು ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಈಗ ಆ ಹಳೆಯ ಫಾರ್ಮುಲಾ ಬರಲ್ಲ, ರಿಪೀಟೆಡ್ ರೂಟ್ಸ್, ಬಿಕಾಸ್ m equals 1 comma 1 is a repeated root which repeats twice here. Therefore value of c is given by ಅಲ್ಲಿ ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿದೆ c square by 2 pi n double dash of m, ಎಲ್ಲಿ ವರ್ಕಿಂಗ್ ರೂಲ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದೆ ಇದನ್ನು, c into pi n dash of n minus 1 of m and plus pi n minus 2 of m equal to 0. ಅದು ಜನರಲ್ ಫಾರ್ಮುಲಾ. ಇಲ್ಲಿ n ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? ಹೈಯೆಸ್ಟ್ ಡಿಗ್ರಿ. ಹೈಯೆಸ್ಟ್ ಡಿಗ್ರಿ ಪ್ರಾಬ್ಲಮ್ ಎಷ್ಟು ಅಂತ ಗಮನಿಸಿ. ಹೈಯೆಸ್ಟ್ ಡಿಗ್ರಿ is 3. ಇಲ್ಲಿದೆಯಲ್ಲ, this is 3. So highest degree is 3. So therefore what you will get is c square by 2 into pi 3 double dash of m plus c into n 3 ಕೊಟ್ಟಾಗ 3 minus 1 2 ಆಯ್ತು, pi 2 dash of m plus n ಗೆ 3 ಕೊಟ್ಟಾಗ pi 1 of m, 3 minus 2 ಅಂದ್ರೆ 1, pi 1 of m equal to 0. That is c square by 2 into pi 3 double dash ಅಂದ್ರೆ pi 3 dash of m ಇದೆಯಲ್ಲ, ಅದನ್ನ ಇನ್ನೊಂದು ಸಾರಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು. ಇದನ್ನ 3m square minus 2m minus 1 ಇದೆಯಲ್ಲ ಇಲ್ಲಿ, ಅದನ್ನ ಇನ್ನೊಂದು ಸಾರಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು. ಇನ್ನೊಂದು ಸಾರಿ ಮಾಡಿದಾಗ 6m minus 2 ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಬಿಕಮ್ಸ್ 6m minus 2 plus c into pi 2 dash of m. pi 2 of m ಎಷ್ಟಿತ್ತು? pi 2 of m 2 plus 2m minus 4m square ಅಂತಿದೆ, ಅಲ್ಲಿ ಮೇಲ್ಗಡೆ ಬರೆದಿದೆ ನೋಡಿ. So 2 plus 2m minus 4m square na differentiate ಮಾಡಿದರೆ you will get 2 minus 8m. So that is 2 minus 8m plus pi 1 of m. Pi 1 of m value na list ಮಾಡಿದ್ರಿ, it is 1 plus m. So therefore you will get 1 plus m equal to 0. Now you have to simplify this. for m equals 1, m equals 1 substitute ಮಾಡಿ ಈಗ ಈ equation ಅಲ್ಲಿ root m ಗೊತ್ತಿದೆ ಎಷ್ಟು m equals 1 repeats twice ಅದರಿಂದ ಆ m equals 1 ಅನ್ನು substitute ಮಾಡಿದ್ರೆ 6 minus 2 plus c into 2 minus 8 plus 1 plus 1 equal to 0. This is for m equals 1. ಆವಾಗ ಅದನ್ನು simplify ಮಾಡಿದ್ರೆ you will get by taking the LCM and simplify this 2c square minus 6c plus 2 equal to 0. ಇದರಲ್ಲಿ ಇನ್ನೊಂದು ಕಾಮನ್ ತೆಗಿಬಹುದು ಯಾವುದು 2 ಕಾಮನ್ ತೆಗೆದು you will get c square minus 3c plus 1 equal to 0. It's a quadratic equation. Which equation? C square minus 3c plus 1. Quadratic equation solve ಮಾಡೋದಕ್ಕೆ ಫಾರ್ಮುಲಾ ಇದೆ ಏನಿದೆ minus b plus or minus root of b square minus 4ac divided by 2a ಅಂತ ಫಾರ್ಮುಲಾ ಇದೆ. ಆ ಫಾರ್ಮುಲಾ ಉಪಯೋಗಿಸಿದ್ರೆ minus b ಅಂದ್ರೆ you will get 3 plus or minus root 5 divided by 2. So c plus or minus root 5 divided by ಎರಡು ವ್ಯಾಲ್ಯೂಸ್ ಇದೆ c ಗೆ ಒಂದು 3 plus root 5 by 2 ಇನ್ನೊಂದು 3 minus root 5 by 2. Thus the asymptotes are y equals x plus 3 plus or minus ಇದರಲ್ಲಿ ಎರಡು asymptote ಇದೆ ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಒಂದು 3 plus root 5 by 2 ಇನ್ನೊಂದು 3 minus root 5 by m ವ್ಯಾಲ್ಯೂ ಮಾತ್ರ ಒಂದೇ m value here is 1 therefore y equals mx ಅಂದ್ರೆ 1x plus c value ಎರಡು ಇದೆ 3 plus or minus 5 root 5 by 2. So therefore totally you have got 3 asymptotes. So simplify ಮಾಡಿದಾಗ you will get 2x minus 2y plus 3 plus or minus root 5 equal to 0. So all the asymptotes are x plus y minus 1 equals 0, 2x minus 2y plus 3 plus root 5 ಒಂದು plus ತಗೊಂಡಿದ್ದು ಇನ್ನೊಂದು minus ತಗೊಂಡಿದ್ದು. Totally it has 3 asymptotes. So what is the degree of the equation here? 3. Highest degree is 3. Therefore it should have at most 3 asymptotes. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ asymptotes ಇರಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಅದರಿಂದ it has 3 asymptotes because no asymptote parallel to coordinate axis. It has only 3 oblique asymptotes and those 3 oblique asymptotes are listed as x plus y minus 1 equals 0, 2x minus 2y plus 3 plus root 5 equals 0, 2x minus 2y plus 3 minus root 5 equal to 0. I will give you some more problems as an exercise. You work out these problems. Only thing is you have to find not only oblique asymptotes for these problems, but you have to work out the asymptotes parallel to coordinate axis and also parallel to x-axis and also y-axis and oblique asymptotes for these problems. You work these problems. If you have any difficulties in working these problems, you please inform me so that I will work it out and place it on the screen. So in the next class, tell me which problem is very difficult for you to solve. I hope that you have understood the matters given now regarding asymptotes here, and you will practice these problems for the examinations because they're all 5 marks problems here. So in the 2 marks, you can guess only asymptote parallel to coordinate axis. But for 5 marks, you have to find oblique asymptotes and also asymptote parallel to coordinate axis. I hope you have understood all these topics. If you are having any doubts, the doubts are welcome. So have you understood these topics? Yes?
Yes, sir.
Yes. Okay. The Zoom time is ending now. I shall conclude this. Thank you.
Thank you, sir.
Okay, right.